Hi everyone. We will learn about the load test experiment, which can inject the chaos or the load on a target application. So we will generate a load on the online boutique application, which is a microservice in an e-commerce website. So we can discuss about all the tunables present for this fault. So we have a total chaos duration, which is the duration of the chaos. So we can change this value to the 60 second, and we have a chaos interval. So here we want a one iteration. So that's why I'm changing it. If we are keeping it same as the total chaos duration, we can change this accordingly, and based on that, it will run for those number of iterations. So we have a users. So user is the total number of maximum user which can be present at a time. So these are the concurrent users at a time. Uh, and there is a spawn rate, so it is the rate at which it will create the those number of users per second. So it is the 100 user per seconds it will allow. And we have a host, so this is the URL of the applications where we want to generate the load. And we have a load type where we can provide the load. And we have a replica, so replica is the at the number of replicas from which we wanted to generate that load. So right now I'm just providing a one replica. And here we there is a prerequisite. So if we can see in the doc, so there is a prerequisite. We need to create a config map. In config map we can provide that script. So in our case, we are calling a get API for that as part of the load testing. So in the script, we are directly providing the self.client.get. So it will call that get client for all the users with that spawn rate. So we can change the script based on our requirement, and then we need to mount this config map to the experiment pod. So we need to create this config map in our cluster. So you can see I have already created the config map in my infra namespace, which is at C in my case. So here I have created a load config map, which is same as what is provided in the documentation. And then we have already provided this config map details here. So you can see we are using that config map, that config that file from tmp/load, and that is already mounted. So we have already provided it part of a chaos engine. And then we have a load test image, which by which by using this image we are creating the helper pod. So we have a one probe here, which is app health check. So which is checking the health status of the front end in the start during the chaos injection. In the from the start to the end of the test, it will check the health status of the front end. So front end should be healthy during the chaos injection. So we can run this fault. So we have a Prometheus dashboard as well. So we can see this dashboard. So we have a multiple dashboards here, and which are configured to the different metrics. So here we have a like front end QPS and a cart QPS. So these are the like where we can see the query per seconds here. So right now without chaos, the QPS is like between 400 to 500. So right now it is 5 to 5 operations per seconds. So the chaos has already started. So we can see the front end. Yeah, so right now we can see the front end QPS is spiked up. So it is increased to the 4K operations per second. So earlier it was 525 operations per second. So it increased to 4K right now. So because we are generating a load on that host, which is the front end URL. So we can try to load this as well. So yeah, so load is there, but yeah, our application is able to handle that load. So that's why the application is still up with that load, 4K requests per second. So we can wait for the chaos to be completed. We can see that this app health check probe is passed because our like this front end service was healthy from start of the test to the end of the test. Uh, our application was able to handle that much of load. Yeah, so as the chaos is over, we can see the metrics are again dropping to the normal value as we have stopped generating that load. Also, we have a like probe success percentage, which is checking the liveness of the front end application here. So we can see earlier it was 100%, but with the chaos, it has dropped to 98.5%. So for sometimes, because of that load, it was but slightly down. So because we are generating an average value, so maybe one or two requests was failed. So yeah, so chaos is completed. We can see the resiliency score is 100 because all the probes are passed.